Good afternoon, everyone. I'm here with Scott Thompson from the architecture firm Weber Thompson in Seattle, Washington. And their building, which was constructed last year?
About a year and a half ago.
Year and a half ago. It was the first commercial building in almost 60 years in the Seattle area to be built with mechanical HVAC. So Scott, thank you very much for spending some time with me today. So first off, what was the impetus for building this without mechanical HVAC?
Well, yeah, it started again about 6 years ago, and what was happening, our firm's been in business for 22 years, and at that time we were growing quite a bit. And the building that we had been in this neighborhood, South Lake Union neighborhood, a couple blocks to the northeast of this building, the owner got wind that we were looking for other options in terms of either doing an adaptive reuse of an existing building or doing a brand new building. We wanted to stay in this neighborhood, so I had lunch with him one day, and he said, well, we have a piece of property that's available. We have a family who's owned the property for quite a few years. They're willing to participate. We have a prime developer who's interested in participating in the project, and if you take the bulk of the building, perhaps we can put something together. So what we did initially was we had several focus groups in our firm. We did a survey, and we asked the question, what would you like to see in the building if we had the opportunity to do anything we wanted in a commercial office building? Two things came back very early, and they're very strong in their commitment to this: natural daylighting and natural ventilation. So the design team basically took off from there, and this is pretty much how we came up with this design. So.
Okay. And so the actual width or depth of the building is 38 feet, which is quite a bit shorter than most commercial spaces. Is there a standard size commercial space, or is it just fill as you go?
Yeah, well, it's basically what we did is we took cues from how we used to do buildings before air conditioning was introduced, which pretty much after World War II, every commercial building in the country had air conditioning, HVAC, put into the building. It didn't matter if you were in Anchorage, Alaska, or you were in Phoenix, Arizona. That was the standard. So what we did is we looked at how buildings were designed in the past before air conditioning was introduced. And it turns out that a lot of these commercial buildings were designed in what were called alphabet buildings. So in this case, what we've done is we've designed a building that wraps around the central courtyard. And again, that central courtyard acts not only as a social spot, but it also acts as a thermal, as a chimneys, a Venturi effect. So what you do is you basically have to keep your floor plates shallow. In this case, we're at 38 feet. You can go from anywhere from 38 to about 45 feet. Mm-hmm. And again, what that does, that promotes optimal daylighting, and it promotes natural ventilation. This building has no HVAC, no mechanical ventilation in it whatsoever. It's all passively cooled.
And how has that worked out? This past summer, Seattle got 104-degree temperatures for a day or two. What was the temperature like in here?
Well, those aberrations, again, now hopefully that's once in a lifetime event that we had last summer. When it was 107 degrees outside, we peaked in here at about 97 degrees, and that was at 7:30 at night. So again, there's no way you can design a passively cooled building to accommodate those kinds of temperatures. But what we did early on, when we were designing this building, we had a mechanical engineer, Stantec Engineering, Tom Marseille in particular, who worked very closely with us. And as this shape evolved, they did a lot of thermal modeling for us. And what they told us is that between 18 to 21 hours a year, we will exceed 85 degrees in this building. This is a temperate, mild climate in the Northwest. So, you know, typically the warmest period of the day comes between 4 and 7 o'clock. And what's interesting about this building, when I think of interior space, you would think at 80 degrees it starts getting fairly warm. Mm-hmm. But this building, if we have a nice breeze blowing through here at 80 degrees, is still very, very comfortable to work in. Mm-hmm. So it reminds me to some degree of being outside and being under a tree, during the summer times.
Mm-hmm. And did you shift work? Did people shift work hours during those few days?
We do, yeah. So typically we'll come in a little bit earlier and leave around 4 o'clock or 5 o'clock, something like that. And in terms of thermal comfort, we're fairly relaxed here in terms of the clothing that you wear. If it's 80 degrees, 85 degrees, no problem with shorts and flip-flops and a t-shirt if in fact that is what is needed for the day.
That's good. And what have you seen on the energy costs so far? I mean, without the mechanical HVAC, that's a large component in any building, the component of energy usage. Have you seen the large savings?
We have, yes, and we've tracked over the first year. And typically a Class A office building in the country, the KTBU output per year is about 80 per square foot. Mm-hmm. And what we're finding in this building, in particular in our office space where we designed optimally for passively cooling the building, we're performing at about 40 to 41 KTBUs per square foot. So you can see it's just a little under a half energy savings.
That's great. So kBTU is 1,000 BTU or British thermal units.
That's correct.
Okay.
Yes. So
great. And that's for spacing or total energy usage?
That's total. That is total energy use, including gas, natural gas for heating the building, and then the electricity.
Okay.